Okay, guys, what's up? Okay, this is something where we're going to start today, tomorrow. It's called out. Okay, is what they call polyatomic ions. Okay, I know we just started using our flip charts, and we haven't practiced those other than the samples that I did in class last Tuesday and Friday, AB, and I sent out a little quick reminder yesterday. And then I posted the periodic table, little 5-minute explanation about D blocks, P blocks, stair step, and all that. That I know every one of you watched it 15 times. I know. But anyway, so this is a little extra something that's kind of like a little extra side rule, term called polyatomic ions. Poly meaning many. And this is a sheet, you'll have a hard copy, but when you get in person, all right? So don't worry about that. See, I'll have a bunch of these. I'll give them to you when I see you next. But I needed to talk about this because many times, just like CO2 or C6H12O6 or something like that is already an established compound, sometimes there's little ions that are put together naturally that form substances that then we add into compounds as already formed little compounds like mixed stuff already that make the cation and anion or the compound that we're naming. And many times, the majority of the time, these are going to be the anion, the second one, but you can have a compound that is a combination of two polyatomic ions. We probably aren't going to go to that level, but I just wanted to say that when we practice it. But when you see these polyatomic ions, you will usually see them in the anion, which is the second one. Okay, so these are the ones we're going to use to practice with here. And here's like acetone, hypochlorite, chlorite, chlorate, perchlorate, so on. Cyanide, poisoning, carbonate, chromate, dichromate. So these are the names. And then here's the little compounds. Okay, so you notice with this, like for example, acetate, okay, is made up of C2H3O2 with a -1 charge. Just like the charges have in individual elements, these polyatomic ions are going to have a charge as well. And they're going to be listed as -1s to -2, possibly a +2, like for this for mercury 2, or H2O, depending on, but most of them, if you notice, are going to be negative charges, okay, that we'll use simply because they're always going to be usually associated with the anion. But here's like ammonium, cleaning product, ammonium, NH4 with a plus charge, it's the same as saying a +1, okay? So basically what you'll be dealing with is we follow our same rules the same way. We'll still say, look at the cation, is it on this side or this side of the stair step as far as the rules, okay? But then once we do the cross-crissing, all right, for example, if let's say that the element that we're naming is Fe parentheses C2O3O2 with a 3 out here. Wow, that looks pretty fancy, right? So here's what I'm going to name, okay? All right? So this is because you see capital letter, look, you know that this is the cation right here. And then when you see these parentheses, what this is telling you is when I have multiple capital, oh, oops, sorry, that's an H, duh, H, okay? I know that this is a compound within a compound, or a polyatomic ion. So I would look at this little chart you gave me, and we'll get used to recognizing it, okay? And we'd say, oh, okay, I know that's iron. There's no element that has a multitude of capital letters over there, so I know it has to be something special, because if it was an element, it'd have a lowercase, but it doesn't. So I look, it's acetone. So this is iron 3 acetate, okay? Because we know it, but we have to write it out. I know this, but we still use our same rules. So, i.e. example, showing you the polyatomic ions. So, I would do the same rules as stair step. Is this, on the left or right side? We know iron's on this side, so we're going to use our first set of rules, flip chart. So, rule number 1, is this a D block metal? Yes, it is, because you already locate that. It's located element 20, 25, right in the middle of the D blocks. So then I would do my cross-cris technique, okay? So, uncrossing this, see the parentheses out here. What this is telling us is I have 3 large molecules of C2O3, oh gosh, I did it again, H3O2, C2H3O2, guess what, C2H3O2. So what this is saying is, I have these 3 bonded molecules all separately, because 3 of this is still parentheses, that are all attached to this iron. So it looks probably something like this. If this is my iron in the middle, probably they're attached like this. Kind of looks like a jacks, okay? So probably what I have is I have boop, boop, and boop, and here's my Fe in the middle, Fe molecule in the middle, and probably attached. So it looks something like that, and then I have each one of these molecules here, here, and here, okay? So I put the parentheses because if I didn't, I would get confused and this would look like O23, which it's not, right? Because these are separate. So then the same rules are the same as we've already talked. Either way I'm practicing. We uncross the charge. So we know that this 3 must be up here. And because this was Fe by itself, because look, this is -1, we knew that this was going to be a -1. So by this uncrossing, we knew that this was going to be iron 3, because the 3 goes up there, and then I go to rule number 3 and name the anion. Well, it's right here, acetate, and I don't do any change. Acetate, okay? So, there it is. So, getting used to recognizing, and this is just like the charts, your periodic table, your flip chart, and your polyatomic ion chart, you can have out in front of you all the time. Okay, I don't expect you to memorize these, but you'll notice sometimes you'll see those. Let's take chromium. Oh, here's a tricky one. Let's take chromium nitrate. So let's take CrNO3 parentheses 2. Okay, so there it is. Parentheses tells me this looks like this. I have Cr, whoops, made a capital. Cr attached, whoop, and whoop. I have 2 molecules of NO3 attached to it. Okay, so hopefully visually that shows you, because the parentheses tells me I have 2 large molecules of NO3 attached to this 1 molecule of chromium. Okay, so let's do the other thing. Yes, it's on this side. Yes, it's a D block. Okay, so then I uncross the 2. So that goes like that. So that is chromium 2, Roman numeral. Only use Roman numerals with D blocks and P blocks. Okay, and then obviously capital N, capital O with the 3 is not an element because there's a capital. So I would look at my polyatomic ion sheet. Oh, here it is, nitrate. And this is chromium 2 nitrate. Ta-da, all done. So it's just basically getting used to identifying polyatomic ions, and you have this chart in front of you, and that was a new little tidbit, last little tidbits we'll learn with the naming, and then as soon as I get you guys back in person, this is what we're going to spend a good week on, learning how to do this, okay? All right, practicing this, doing the work in class, completion stuff with that, checking that, learning how to do that, so then I can do you a celebration of knowledge or give you a little testing on that and go from there, all right? Because you guys will master this, because this is easy stuff, because you got all the necessary sheets. You have this, periodic table, flip chart, all in front of you. All you gotta do is follow the rules. What is it given to you? Repeat, and so on, okay? So that is this polyatomic ion sheet that I showed you, okay? So now let's bring us to our assignment for today, okay? So before we start uncrossing and naming, we need to practice making compounds, okay? So I'm going to go to my drive, and I'm going to click on my crisscross sheet here, okay? And obviously I can't, it's not putting it completely up there on the board, but your sheet that we uploaded will look just like this, okay? All right. And basically what this is, troops, is notice this is sodium with a plus charge, because there's sodium +1. Okay, looking at that. So you notice the little charge next to these are just the straight elements by themselves. And notice up here, polyatomic ion, OH negative, SO4 -2, PO4 -3, and O3 negative. So those are polyatomic ions right here on this sheet. They look identical because, oh look, SO4, oh that's sulfate, so that's your polyatomic ion and so on. So basically what you're going to be doing with this, troops, is practicing drop the charge, drag down the number. So what that means is it's a little, I call it a roadmap chart. So you're just going to fill each block. So for example, you bring sodium, these are your cations, and these are your anions. Okay, so these are all going to be the first elements. So if I have Na plus and Cl negative, that's a +1 -1. I drop the charge, remember, so I drop the plusy, and I just bring it down, which would be NaCl. So that would look like if I have Na plus and Cl minus, I drop the charge, bring it across, and I make this here. Okay? Ta-da! And remember, you don't put 1 and 1 down there. Just by showing the symbol for the element, that is the same as saying 1. Okay? So you don't do that. All right? So you see how I did that. All right? Let's take the next one right here. Na plus S2. So if I'm just showing your Na plus with an S with a 2- charge, because sulfur's over there in the -2 column. So how do I make that a compound? Well, I drop the charge, crisscross the charge like so, and that gives me Na2, because the 2 came across, S got a 1, Na2S. Ta-da, compound. Sodium sulfide. Okay? See how that works? Of course it does. I see how that works. Okay? Take the next one. Dun-dun-dun. Dun-dun-dun-dun. I have Na plus, okay? And I have OH with a negative, okay? That is, actually I know that's sodium hydroxide because I know this, because I teach it, okay? But it's irrelevant. So what does it say? Okay, element, bring them together, drop the charge, take away the plus minus, 1 and 1. So that gives me NaOH. Sodium hydroxide. Makes sense? No worries, no problem. Okay? Alrighty. Let's do, tricky one. Alright? Let's do, well, it's not a tricky one, but let's do the second column here. Let's do calcium and sulfate. So here it is. Ca with the 2 plus, and I got SO4 with the 2 minus. Okay? So I'm filling in this box right here. Beep, 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 beep. Filling in that one. Okay? All right? So what this is saying is, same thing. Drop a charge, get rid of the plus, get rid of the minus. 2 comes across, 2 comes across. But it's like fractions now. When I can cancel or reduce, that's the better word, reduce like a fraction. So instead of writing this as Ca2 SO4 parentheses 2, because I had to put parentheses, otherwise that'd look like SO42. I cancel those out because I noticed 2 and 2 things. So it should be written as CaSO4, calcium sulfate. Okay? All right. So I wanted to introduce this today. Okay? So you have a large chart of all these little compounds. So I wanted to introduce this to you, and I want you to try it. Probably be best if you do this in pencil, or maybe if you're a person that prints this out, do this in pencil or print it and do it on pencil or something, because when I see you next, we're going to start working on this and double check and practice all this stuff because it's necessary. So like, let's take for instance, here's another good one. Let's try a different version here too. Boom to boom. So let's do this one right here, which is iron and hydroxide. So get a better pen, purple one here. So we're dragging this, we're doing this box right here. Okay? All right? This will be one practice using parentheses with a polyatomic ion. Okay? So, if I have Fe 3 plus, and I have OH with a minus, OH with a minus. Why am I talking in a dumb accent? I don't know. Okay, so just like always, drop the charge. Drop the charge. Drop it, minus, plus. 3 will come down here. 1 will come down here. Okay, but here's the only thing when you write it different is you would write it Fe by itself, so it's going to be Fe because of 1. But instead of writing OH with a 3, because if you write it like that, remember, this is a separate group within a group, right? So what this is saying is, if I write it like this, oh, I have 1 oxygen with 3 hydrogens. That's not what I got. Remember, this is a compound. This is hydroxide. So I put a parentheses, so that what that tells me is, oh, I have 3 OHs. So it would look like, if this was my Fe, my iron molecule, I have an OH, an OH, and an OH attached. Okay? That tells me I have 3 molecules of hydroxide attached to that iron. Because if I didn't put those parentheses, guys, it would look like this. It would look like I'd have an iron, then I'd have 1 oxygen coming off here, and then I would have 3 H's. Okay? So from a symbol standpoint, oh, it's kind of like a stick figure dude. Hi, put some horns on him, some ears, maybe make some wings, and I got a turkey! That was not, okay. Anyways, yeah. But you notice, I had to been done, okay? All right? I would have done it here in class with you, so you can't give me any courtesy giggle laughs, right? But hopefully you're just shaking your head going, he's not right. I think he's been out in the snow too long or something. Okay, so once again, parentheses, make sure that it shows me it should look like this. OH, OH, OH. That's what it should look like. It tells me I got 3 hydroxides and not like my little funny stick person that would have looked like this with an oxygen, H, H, and H. Okay? That completely looks different how it's all bonded up. That's why the parentheses shows it how it should, as opposed to if I would have left them off, that's what would it look like. Okay? So what you're going to continue to do is continue through this, practicing this, and I showed variance, okay? Being careful about when you have same elements, you reduce down to that or parentheses, but we'll practice it. But I need you guys, and I know, you can only watch so much YouTube and Netflix and gosh knows what else, or sleep till 4 p.m., stay up till 4 a.m., sleep till 4 p.m., okay? So these I'm going to upload, all right? So I'm going to send out an update, so you'll see this, say, hey, I need you between today and tomorrow doing this, because hopefully Thursday I'll see you. If I don't, we'll go from there, because it's supposed to continue to get cold and all that good stuff. But I need you to move forward with this stuff, okay? All right, so that's where we're at right now. Okay, we need to practice crisscrossing, making compounds a little bit, the charge, drop charge, bring numbers down with this before the naming, all the other stuff. Got a lot of stuff on our table, but we're at the point now where it's practicing and learning, because I went through all the rules and the notes and everything, and if you're right here in front of me, we'd be going over all this stuff, okay? So I'm going to go ahead and stop this, upload this, update this, and all this good stuff for you, so you have this at home, okay? All right, and then I'll see you hopefully real soon. All right, troops? Bye.